Hey guys, welcome to day 85 of Codeforces Every Day until GM. Let's just get straight to solving problems. Today we have a 1300 rated. This is the problem of the day in the Discord. Come join if y'all are new and see if y'all can solve it. Rating 1300. Okay. Given two arrays A and B, both of length n, elements of both arrays index from 1 to n, you are constructing a directed graph where edge from U to V exists if AU minus AV is greater than BU, greater than or equal to BU minus BV. A vertex V is called strong if there exists a path from V to all other vertices. A path in a directed graph is a chain of several vertices connected by edges such that moving from vertex U along the directions of the edges and the vertex V can be reached. Your task is to find all strong vertices. For example, if A equals 3, 1, 2, 4, and B equals 4, 3, 2, 1, the graph will look like this. Okay, our first input, T equals int input, as per usual. And then for in range T, we take in n equals int input, and then we take in an array. A equals list map int input split. Okay. And then we take in a B. B is an array too. Bang. Alright, what do we have to do? Find all strong vertices. A vertex is strong if there exists a path from V to all others. So in this example, where are the strong vertices? What is our output? First line, number of strong vertices, and then all strong vertices in ascending order. So we're saying number of strong vertices and all strong vertices in ascending order. So this case has one strong vertice for two. Why did some of them have two numbers? Oh, I guess if they're the same strength, right? So there exists a path from V to all other vertices. Like 4 is a strong vertice here. 3, 5. Am I not looking at the right case? Oh, this is case 1, right? There's one strong vertice and it's just 4. And then this is the second case, right? I see. I understand. So the strong vertices in this case is just 1. Wait. Path from V to all other vertices. So never mind, it's not 1. It's 5, 3, just 5 and 3. So there's 2, 5, or 3, 5. And ascend. Oh, I understand. Okay. So we're given two arrays, right? What are the two arrays? 3, 1, 2, 4. You are constructing a directed graph where the edge from u to v, u does not equal v, exists if AU minus AV is greater than B. Okay, wait. So this is telling us how we should construct this, right? But I don't really get it. 1, 3. So it's like this, and 2, 2. What does that mean? AU minus AV. BU minus BV. An edge from 3 to 1. AU. Huh? I don't really get it. I don't really get how to create these. Edge from U to V exists if AU minus AV is greater than BU minus BV. So 3 points to huh. 1, 2, 4, 1, 2, 5, 2, 3, 3, 1. Wait, how exactly do we draw these graphs? Where to go? Here it is. Edge from U to V exists. AU minus AV. Is this what it's saying? I have. Huh? Okay, so we're gonna have uh vertices 1 through n, so 1, 2, 3, 4, right? We're gonna have 1, 2, 3, 4. From 1 to 2, 3 minus 1 greater than equal to 4 minus 3. This is 1, 2. This is correct. So an edge from U to V exists. Like this. And then from 2 to 3, we have 1 minus 2 greater than equal to 3 minus 2. This is 1. This is negative 1. This is not true, so there's no arrow here. Instead, it's like this. Is that the case? But then 3 to 4. 2 minus 4. 2 minus 1 is 1. Negative 2, this is not the case, so no, it's from 4 to 3. And then 4 to 1. 4 minus 3. 1 minus 4. Negative 3, 1. This is true, so there's this edge. And then 4 to 2. 4 minus 1. 1 minus 3. Negative 2. It's true, so 4 to 2 exists. Now 3 to 1. 2 minus 3. 2 minus 4. Negative 1. Negative 2. So 2 to 1 does exist. Okay, I kind of see how we draw these graphs now. But, like, I can't just simulate this graph draw. Right. That's not the point of the problem. Is there anything that stands out to me right away? So my intuition is thinking, something along the lines of 4, 1, 4, 2, 4, 3. So we compare 4 against every other node. Right. This is less than this. It's some sort of difference thing. I think you have to take the difference between the two arrays first, or something like 3, 1, 2, 4, 4, 3, 2, 1. We're left with negative 1, negative 2, 0, 3. Now, because this is the same condition as AU minus BU greater than or equal to AB minus BV. And this is just AU minus BU. Now we just count for ties, right? In this second case, there are 2, 3, and 5. So 1, 2, 4, 1, 2, 5, 2, 3, 3, 1. Negative 4, 0, 1, negative 2, 1. Oh, this might just be the solution. You subtract the 2 and then pick the greatest index. right? It's of n. I think so. That wasn't that bad. I mean, assuming it's the correct answer. Um, for I in range, for I in range in diff dot append ai minus b I target equals max diff array uh and then what do we need to print out? We need to print out an array. We can do this. We can also do why did we call this difference array? Let's call this diff array. Shorten everything up. For I in diff r, if I is equal to target. Oh, we need an index, so in range in is equal to target to print plus equals 1. To print dot append diff r. No, we just append I plus 1. Print len to print star to print. There we go. That was not bad at all. That did not feel like 1300. That was an easy 1300. I feel like every time they start messing with like a data structure or something, the problem is just like worth more points. Like if this was or like is like overrated. Like if this question was just like a string question and there was 1300, I would be struggling way more on this, I feel like. Let's take a look. Um it is all in Russian. Is it D? Okay, it's not. Alright, yeah, their first step was the same as my first step. I knew to do this because there was a similar question that I've done before. I forgot which one it was, but you like rearrange the array. I might have made a video on it before, actually. Is it? It's not books, right? Grid reconstruction. Hey guys, welcome back. Today let's... No, not this one. Oh, I don't know. I don't remember which one it was. I wish I could pull it up for y'all, but I forgot. But yeah, it seems like... their answer is pretty much the same, or their reasoning is pretty much the same as mine. So, great. 1300 solved. Problem of the day solved. Let's do another. Let's do a 1200. Fancy coins. Did I make this one a problem of the day? Because I've definitely missed a few problem of the days, but no. Okay, let's do it. Rating 1200. Binary search. Monocarp is gonna make a purchase with cost of exactly M burls. He has two types of coins in the following quantities. One coin worth 1 burl. Regular coins. Wait, coins worth 1 burl. Wait, what? Two types of coins in the following quantities. Coins worth 1 burl, A1 regular coins, and infinitely many fancy coins. Coins worth K burls, AK regular coins, and infinite many fancy coins. What does this mean? Monocarp wants to make his purchase in such a way such that there's no change. The total worth of the provided coins is exactly M. He can use both regular and fancy coins. However, he wants to spend as little fancy coins as possible. What's the smallest total number of fancy coins he can use to make a purchase? T equals int input for blank in range T MK A1 8K map int input split. Okay. The cost, the worth of the second type of coin, the amount of regular coins of both types. Okay, so amount is total number, the worth. Okay. I think I get it. So he has one coin worth 1 worth K. Uh, there's a fancy coin. In the first test case, there are no regular coins of either type. Monocarp uses 2 fancy coins worth 1 burl and 3 fancy coins worth 3 burls. What? So, cost, he needs to make 11. 3. 5. Okay. Uses. These are the amounts of regular coins of both types. What is a regular coin? There's 20. A lot of regular coins of both types. So you can use 11 worth 1. Doesn't have to minimize the total. What is the smallest fancy coins? Doesn't have to minimize the total use of coins. That way he uses fancy, 0 fancy. Okay, so these are oh, so the fancy coins are worth the same amount as the regular coins, but since they're fancy, he doesn't want to like use them, right? So he wants to use as little as possible. That makes sense. So these are the regular counts. Isn't this just brute force? We want to make 11, or we want to make n. So let's just use up all our regular coins first. N minus equals AK times K. N minus equals A1. Oh, we're gonna just do minus A1. If n is less than equal to 0, print 0, continue. Now, $11. No change. Now we greedily use okay, we should track to print equals 0. We greedily use we greedily use AK coins. N equals N divided by AK. N minus equals to print times N. To print plus equals N. Is my logic here correct? It seems like this is just the answer. Like, what am I binary searching? Oh, division by 0. AK can be 0? I guess it can. We should divide by K, not AK, and then times K. Okay. So this third case, we would greedily use coins So 11 minus 3 is 8. And then minus 6 is 2. So 2 divided by 3 is 0. So it would still be 2 after this. And then this. What? Print 2 parents. Let's isolate this case. 4, 2, 6. This is giving 4? 14. AK is 1 times 3 minus 6. 9. 11. Yes, this is correct. How am I getting 14 here? That's correct. So this isn't correct? This is an order of operations thing. So I can very much just do this. 2. Okay. Or it should be 1. Okay. Oh, shoot. It is 1. We can't greedily use... because of what we want to do. This logic is incorrect. It's not good to just use all of the coins. All of the normal coins, because then we can use one special coin. Well, it is correct to do this. It's just we need to check for the last coin. If If we add back a k, no, if we add back a 1, what if it's like a number of 1s? If k, what am I thinking of here? So in this case, we get to add back a 1, be 3. But say we got to 2 and our thing was 4. We would add back a 2. So really it's how much we should add back is k minus n. If k minus n is greater than 1, is greater than k minus n but n could be like 12. It's 12. Four divided by 14. Okay, if it was 10, if n was 10, the thing was 4, we would add back 2. So it would be n mod k is how much we should add back. If that number is greater than When is it better to add back and when is it not? It's always better to add back, no? So if we were to simulate always add back, we need to print equals 1, and then in would be n plus equals n mod k. 10 mod 4 is 2. 11 mod 4 is 3. It's k minus. Alright. Do I need this? I don't think I need this. It should just be this. No? Okay, so in this case, we would... In the first case, it's wrong too. 11, 3, so first... Okay, we only do this if... When do we do the add back? We want to make 11 with 3. We greedily use specials. So we would do 3. But for the third case, that 2. And we do the add back, which is 3 minus 2 is once we add 1 back. So the problem is we get to here, and then we're doing 3 minus 11 mod 3, which is 3 minus what? 3 minus 11 mod 3, which is 3 minus 2, which is 1, which means n is 12, which means 2 print is 12 divided by 3, which is 4, and minus equals 12. What is going on? Received 4, expected 5. Now this is not right. We only do the add back if so we need to add a condition for the add back. So far the most obvious condition is when there's zeros, right? But what if when only one of them is 0? Or what if when, like, say we have 11, 3, 0, 1, then first we'd start off by having 8, right? And then we greedily use this to it'd be 4, which seems correct. But then we have 3, 1, 0, we have 10. Then we use 3, 1, which also seems correct. But we didn't need to add back here. We need to add back only when twelve, 10 is closer to 12 than it is to 9. So if n divided by k multiple is n divided by k if abs n minus multiple times k is greater than is less than we do the add back right? No, this is not the right condition. So we have our multiple is 3. Then if 11 minus 12 is equal to 1, and then we have 11 minus 9 equal to 2. I guess we have nothing to add back, huh? And A1 is greater than or equal to this. Okay. Whew. That was some logic. But is it correct? Let's see. Sure. What could be wrong with this? Fifth. Expected 1 found 0. This one? 1201. I guess. Why is this 0? Or why is this expected 1? Oh. Shoot. This doesn't really work, huh? We can only use as much until it becomes negative for the first case. So while n minus k is greater than 0, or is greater than 0, and k is greater than 0, and k minus 1, n minus equals k. While n minus 1 1. Now this shouldn't be the case. Okay. Yes, this is correct now. Now this case. This is correct. Multiple is 0. It is 2, k is 3. So multiple is 0, so the closest is this, right? So we are simply looking for n minus 3 is 1, and then 2 minus 0 is 2. Okay. Okay. Oh my god. What's wrong this time? Bro, case 234. It's some edge case. Some edge case that I'm not getting. What case would it be? Expected 1, found 2. Expected 1. Had. So let's change this to M real quick. What could it be? 4. Is correct. Not like 7 to 1. Do 1 because we'd use. This is all correct. What is wrong with this? This thing breaks. Right? What's our multiple? Okay. Expected is 1. You'd get to 26. Then you would use 12. Get this down to 14. And then you use 1 fancy. And putting M here gets us 7. Shouldn't give us 7. Oh, 53. Yeah, it gets us 7. So we have 7. Now our multiple should be 7 divided by 14, which is 0. So it's 1. Or it's 0, 7, 14. This is 14 minus 7. Well, it's 7 minus 14. Abs is equal to 7. And then 7 minus 0 also equals to 7. When they're both equal, we want to use, so it should be this. Is it as simple as this? Could just be as simple as this. Oh, wrong answer, bro. What is it this time? Oh my god, case 778. It's gonna be so close. What am I missing? Two expected should be see, let me see. 52. 38. And then multiple is 3. So from 36, 38, 48. Okay, so this condition is absolutely BS. We just want to do it. Do we even need this? Is it simply just... Four, which is correct. Because what my thing does right now... Wait, now this is wrong. Why is this 1? Oh, is this it? All that logic was just useless, I guess. I was thinking too deep about it. Oh my god. What else could be wrong? What else could be wrong? The 78th case? Bro. Now we don't want to rebalance at all. Case 3. Actually, even after rebalancing, it's the same, no? This isn't a rebalancing issue. Well, actually it is, because it's 9 for some goddamn reason. It's 3 minus 0. Yeah, so we don't want to rebalance at all. If is 6. Shoot, I need to use mod here. I feel like I'm collecting infinity stones. TLE, oh my god, I'm gonna kill myself. So, okay. TLE on test 5 means logic is probably right. But it's too slow. Oh my god. I'm given 2 seconds. What's my time complexity for this? It should just be O of n. It's O of n. How is this too slow? Is there any way I can do this in O of 1? It probably is. Min AK, K, and then 2U's times K. I can probably just do this. I don't even need this variable. And then I do m minus equals min a1m, and then get rid of this, get rid of this, get rid of this, replace this with a1. This is O1, right? Holy shit, I got it. Oh, this question railed me, bro. The logic was all there. Wow, what a complicated math problem. Okay. We got it. I was gonna do one more, but I did not expect this question to give me such a run for my money. I guess if y'all enjoyed this video, be sure to like and subscribe. Join my Discord. Link for everything is in the description, and I'll see y'all guys next time. Bye.